Hello, welcome to Mathematics Solution. Let us continue with the differential calculus. So far we have checked two methods of differential calculus, two methods of differentiation, and that is the first principle, and also we have checked on the product rule. So today we want to look at what we call the quotient rule. And what is the meaning of quotient? When we speak about quotient, what is the meaning of quotient? So let us look at the quotient. The quotient rule. Quotient simply means division. And so therefore, the quotient rule states that if y is equals to u over v, where u and v are functions of x, then the derivative dy dx will be given by v du dx minus u dv dx, and all this over v squared. If you can remember, our product rule, dy dx was equal to what? It was equals to v du dx plus u dv dx. So if you compare these two formulas, you will realize that in the product rule, it is positive, and in the quotient rule, the numerator has negative. So it means that if you can be able to understand the product rule, then the quotient rule is also easier to master. So let us look at an example. Example find dy dx given, find dy dx given y is equals to x, y is equals to 3x raised to power 4 over cos 2x. So let us look at this question together. Solution. So immediately you have seen that you have two functions, one in the numerator and the other one in the denominator. Automatically, you have to apply the quotient rule. So let us look at this point. In this point here, we have our u and our v. So we have said the quotient rule states that dy dx is equals to v du dx minus u dv dx and all over v squared. So from our question, we can let our u be equal to the numerator, which is 3x power 4, and our v be equal to cos 2x. So therefore, what will be the du dx? So using still the standard table, you know that you take the power, you multiply by the coefficient, so it will be 4 times 3, which is 12. Then you reduce the power by 1, so it would be cubic. And also dv dx as we did also in the product rule, the derivative of cos AX is negative A sin AX. So therefore, in our case here, A is 2, and therefore, you're going to have negative 2 sine 2x. So what is remaining now is simply to substitute and obtain our dy dx. So dy dx is equals to, our v is cos 2x, then our du dx is 12x cubic minus our u is 3x to the power 4, and our dv dx is negative 2 sine 2x, and all this over v squared, which is cos 2x, and all of it squared. So basically, if you have written like this, it is okay and it is right. But then let us simplify. dy dx is equals to 12 x cubic cos 2x. Then this negative at sign, and this negative is going to be positive. So it will be plus 2 times 3, which is 6. 6x to the power 4 sine 2x, and all this over cos squared 2x. So remember we said the cos squared theta is the same as the cos theta times cos theta, and that square comes at the top of the cos. So it doesn't go to the 2x, it's only at the cos. Good. Again, we can factorize maybe 6x cubic, so that we can have our dy dx is equals to 6x cubic into bracket, going to have 2 cos 2x plus x sine 2x, and all this over cos squared 2x. So let us do another example. Example 2. Example number 2. We have example. You have been given determine dy dt given y is equals to t exponential 2t over 2 cos t. Now let us look at this problem. Solution. So you will realize that in this problem, our numerator is a product of two functions. And we said, wherever we have a product of two functions, we apply the product rule. So that one implies that in this problem, we shall apply both the product rule and the quotient rule. So at first, we already have a function in the numerator and a function in the denominator, meaning that you're going to apply the quotient rule. So quotient rule says that dy dt, in this case, will be equal to v du dt minus u dv dt, and all this over v squared. So we can let our u be equal to t exponential 2t, and our v is equals to 2 cos t. So in finding du dt, we're going to apply the product rule. Reason being, u is a product of two functions. Just to make you maybe understand product rule clearly, I want you to remember, if we say that if y is equals to uv, then dy dx is equals to, we hold v, then we differentiate u with respect to x, then plus, we hold the other function, which is now u, and then we differentiate the v function, dv dx. So let us apply the same scenario in finding du dt. So for the du dt, we first of all hold t, we don't differentiate, then we differentiate exponential 2x. The derivative of exponential ax is a exponential ax. So therefore, in this one, we can have s2 exponential 2t plus, now we hold exponential 2t. The meaning of holding is that we don't differentiate. We just take that function as it is. Then now we differentiate t. With respect to t, you'll get 1. Also, let us find our dv dt, which will be equal to negative 2 sine t. So for the du dt, we can simplify. So our du dt is now equal to 2t exponential 2t plus exponential 2t. Then our dv dt is now equal to negative 2 sine t. So the next step is simply to substitute into the function, into the formula. Dy dt is equals to, our v is 2 cos t, and then du dt is 2 t exponential 2t plus exponential 2t, then minus u, which is t exponential 2t, and then multiplied by dv dt, which is negative 2 sine t. And all this is over v squared, which is 2 cos t, and all of it squared. So we can try simplify this. We can simplify this. Dy dt will be equal to, so you can realize that we have a common factor, which is exponential 2t. So, but also you can still first of all maybe open up the bracket. So this is 2 cos t times this one, it would be 4 40 exponential 2t cos t, then plus 2 exponential 2t cos t, minus, now it won't be minus, now it will be positive because we have this negative and negative 2 sign. So this one means that it will be positive 2 t exponential 2t sine t. And all this over, we apply the rules of indices. This one will become 4 cos squared t. So that is our final answer. But you can still simplify by factorizing maybe exponential 2t. But even if you write up that point, it is very much correct. Now, you realize that some questions now it will need you to apply more than one method. Like in this one that you have solved right now, we have applied both product and the quotient. There's a question that we left at the product method or product rule. That one required us to apply also the chain rule. So it means that the moment now you have solved the chain rule, then we shall end back to the same question so that now you can solve using the chain rule and also the product rule. So let us look at another example. So the final example in this one. So example, you've been given y is equals to tan ax. I remember we in the standard table, the derivative of tan ax is simply the a sec squared ax. Let us see how do we go about this kind of a question and how do you obtain the sec. So find dy dx. So what we need to remember, in trigonometry, we said that tan ax is the same as sine ax over cos ax. And so that's why you can now apply the quotient rule to solve for its derivative, because we can treat sine ax as our numerator function, which is u, and cos ax as our denominator function, which is v. Then we end up applying now the quotient rule. So we can have it, our quotient rule states that dy dx is equals to v du dx minus u dv dx, and all this over v squared. So therefore, let our u be equal to sine ax and our v be equal to cos ax. So meaning that du dx will be equal to a cos ax, and our dv dx will be equal to negative a sine ax. Then from there, we substitute now into our formula. We substitute into our formula that dy dx is equals to our v is cos ax, and then our du dx is equals to a cos ax minus, then our u is sin ax, and then our dv dx is negative a sin ax, and all this over our v, which is cos squared ax. So if you open up this bracket, you're going to have dy the x being equal to a cos squared ax, then plus a sine squared ax, and all this over cos squared ax. So you realize that if you factorize a, dy dx will be equal to a into bracket cos squared ax plus sine squared ax, and all this over cos squared ax. So you realize that this one here will be equal to a over cos squared ax, which is equals to a sec squared ax. Why am I saying like that? Because we know that cos squared ax plus sine squared ax is an identity, which is equals to 1. Therefore, a times 1 will have a. We also know from the trigonometric ratio that 1 over cos is a sec. And so therefore, 1 over cos squared ax will be sec squared ax. So our dy dx is equals to a sec squared ax. Thank you very much. Let us meet in the next method, which is chain rule. Kindly subscribe and like my videos. That is the only appreciation you can give. So let us meet in the next session, which will be the quotient rule.